Hi, everybody. Welcome to today's Intro to Tech, where we'll be going over an introduction to Git and GitHub. But before we get started, I have a couple of things to say really quickly here. So first things first, little typo here. If you aren't a member yet, please sign up with that QR code at the top right corner there. If you do so, for the spring semester anyway, you can reap the benefits of being a member. So you'll get a free t-shirt towards the end of the semester. And then there's some other stuff like you'll be eligible for some raffles. And then towards the end, we hold a spring celebration networking event. And so that's just kind of where you, the students, and a couple of sponsors come together and talk to each other. So just make sure that that you attend at least 9 meetings for the spring semester. We're including 2 for Rowdy Hacks, so just be on the lookout for that. And I don't know if anyone's or if everyone has scanned that QR code top right. I'll probably give you guys like maybe 5 more seconds to do that. Okay, so I'll go ahead and continue. So another thing I want to point out is if you are not in our Discord, please join. We often make announcements there. And please be sure to follow some of our other social media accounts, such as our Twitter or Twitch, which some of you may be watching, and as well as YouTube. Just make sure that, if you're on Discord, just keep an eye on announcements. I know we kind of made an impromptu sort of announcement that this is going to be online, and I know it's cold and campus is shut down, so really appreciate you guys being out here today and taking the time from your online classes to just sit here to join. So another thing I want to point out is for upcoming events, these are some events that are coming up. So tomorrow, Thursday, February 2nd, Coding in Color has their open house. It'll be in the Willow Room, 2:30 p.m. to 3:30 p.m. If you're interested in knowing what it's all about, please join. I suggest you do so. But we also will be returning back to ACM general meetings next Wednesday. So instead of an Intro to Tech, we'll just have an ACM general meeting. And we'll be going over some technical interview questions. So this workshop will be there just to help you get your skills or enhance your skills for technical interviews. And I would highly recommend you join that as well. Very good practice, and practice always never hurts. So that'll be 3 to 4 p.m. next Wednesday in the Rotama, which is that probably huge room in the second floor of the Student Union. And finally, a week after that, on the 15th, we'll have another Intro to Tech where I'll be talking about machine learning and introducing you guys to that. We'll probably be using Scikit and PyTorch, but I know many of you suggested last semester for a couple of AI workshops, and I definitely want to follow up on such promise, especially since I said that in open house. And that'll be in the HEB Student Union, room 2.202, or the Travis room. So be sure you're on the lookout for that. And finally, make sure you sign into today's meeting. There's the QR code right there, and check in. So remember that maybe some of you are familiar with last semester. We used just a regular Typeform system. So now we're using a portal where you can check in through a portal, and you'll have points added to your membership count. So just again, make sure that you scan this QR code and you check in online just to make sure that you are getting those points counted towards your membership. And don't worry, guys, if you missed this QR code, I will come back to it at the end of the event just to give you guys another chance to scan it again. But yeah. So, and last thing, if you are from this professor's class, you may have been notified or suggested to join for extra credit. I highly suggest you either go to the link or scan the QR code just to make sure that you're being counted for that extra credit. And I'll leave this up for a couple more seconds. So if anyone wants to, or if anyone would like the QR code towards the end and has missed it, you're more than welcome to let us know through chat, either Twitch or YouTube. Okay, so I'll go ahead and move on then. All right, so I guess we'll go ahead and start an introduction to Git and GitHub for spring 2023. So let me give you a little bit of context. Git itself is a version control system, but you might ask, what exactly is a version control system? Well, they're essentially ways of keeping a track of changes made to files. So if you maybe add a piece of text on, a README file or a Python file or anything of the sort, a version control system will make sure that that change is recorded somehow in some way. Now, some of the questions are, why exactly would you want to bother with a version control system? Well, the primary reason is because it's great for collaboration. So because you keep track of changes, you're also able to see who is responsible for those changes. And also because you can host a code base in a wider range of platforms, you can have multiple people work together on a certain project. And this is definitely useful for a lot of classes where professors might ask you to make a programming project and you are working with someone and you don't have to transfer files multiple times. And it's probably better to do this than, say, having a Google Drive for such purpose. And secondly, what I'm about to teach you is definitely an industry standard tool. A lot of employers really, really seek skills like this. In fact, when ACM has spoken to several sponsors, such as HEB or MITRE, a lot of the common complaints were that students should learn Git and GitHub skills as well as command line skills. And I'm definitely going to try to teach you command line by using a Git bash terminal to make changes to your, GitHub website or GitHub code base. And again, I'll totally introduce some of this terminology a little bit later on. So I kind of mentioned, and you probably heard me earlier, saying that Git is a version control system. So you may have seen through the title that we've also mentioned GitHub. Well, keep in mind that Git and GitHub are not the same thing. So Git itself is the version control system responsible, and this hosts kind of your local repository. However, GitHub is kind of a service, and this is a centralized version of Git. So you basically have these code bases or repositories which are hosted through the cloud or through the internet. And the way this version control system works is that it uses snapshots. So these are like records or moments in time where you have certain changes to your code. So again, just think of it as a list of, what files are being changed and which ones are not being changed, or what the current state is. So again, I sort of mentioned this. Basically, a repository in Git terms, or in terms of Git and GitHub, is basically a code base where, you know, all your code is stored, all your changes are recorded, and so on and so forth. And so, like I said, keep in mind, GitHub has this centralized, so all your code is hosted on their servers through the internet or the cloud. So, and remember that repositories or code bases that you modify on your system are local. So these are entirely on your machine. And this will sort of matter later on when I discuss how exactly you can make changes to your local machine and you can put them on the cloud or through some sort of repository on the internet. So first, let's get started. So what I suggest you do is first create an account on github.com and then proceed to download this Git Bash terminal. So just to kind of show you here, if I open this in a new tab, basically this terminal is a very convenient way for most users to make Git related changes. So if you'll just go ahead and click the button to install for whatever platform you're on, that should be sufficient for now. And then make sure that when you're on GitHub, you create an account. So that'll just be done through just this top corner, and it'll probably ask you to log in or something of the sort. And so once you have created an account and you've also downloaded Git Bash, you do want to make a desired directory a Git repository by doing Git init. But this will be a little different than how I'm directing you guys to do it. So just hang on tight for a sec. So I've kind of mentioned, so before I move on to some of the further parts, you're probably asking, well, how exactly does GitHub or Git, more importantly, keep some of these changes? Well, so commits, so this is done through something called a commit. A commit is essentially just a snapshot or a current state of changes. So this is basically like, again, like I previously mentioned, it is the current state of what all the files in your code base are. But a lot of the question is, how exactly does Git know which files to keep track of and which ones to not? Well, usually you have to add them to the staging directory or staging moment. And this is basically what Git recognizes as files that are going to be changed soon. So you could definitely do this by just saying git add and then whatever file you have changed. Or if you would like to just add all files that you have modified, you can just do git add and then put a dot. And again, I kind of want to, I'll demonstrate this when I go ahead and create a repository and I kind of walk you guys through the Git Bash items. So this is essentially how we would get our local changes to our remote repository and have those changes be reflected in the repository on the cloud. So in order to do this, we'll basically just make a repository and we'll give it simple settings. So with that being said, it probably now is a great time to move on and show you guys how exactly to create a repository. So once you've created an account, what you want to do is you want to click this plus here at the top right corner, and then make sure that you hit new repository. So now what you want to do is you can change the owner. So in this case, I'll just say that this repository will be hosted on the account with or the organization with UTC ACM. And now we can give it a name. So I'll just say, for example, ACM GitHub demo, and then I'll give it a semester, so S23. And then I can just give it a description. So this is a demo of Git and GitHub for spring 2023. And you can choose whether or not you want this repository public or private. I'm just going to choose public, just for convenience sake. And there's a bunch of options here, which don't worry at the moment. Probably what we'll do is we'll just create it now while we're at it. And we'll talk about this, what a README file is, a little later on. So don't worry about that yet. So, oops, my bad. So now that we can create our repository, so now what you've done right here is you've basically just created a repository on the cloud, and now it's sort of like a blank slate here. So now what we can do is we can actually try to get this to our local. So now that we've created a repository on the cloud, we can see if we can pull these now locally. So what we can do is if we go back to so if we open up Git Bash, and what I've already done is I've already just opened Git Bash here and I've directed it to a terminal. And so for those of you who don't know, if you would like to, so this is basically just an interface for the file explorer. So like how you would click through files, this is just done through the command line. So instead of a user interface, your user interface is really just a bunch of text. But to get started we'll just go ahead and try to copy some of these commands. So first things first is this link here is basically just the link to your repository on the cloud. So let's say I kind of want a copy of this repository now to my local machine, right? So what I would do is I would type in git clone and then the link. And essentially what this does is it creates a clone of this repository on the cloud onto our local machine. And if I hit enter, so now it's telling me I cloned an empty repository. Well, this is because there's nothing really in it. And if I see here, you notice that now a folder is created just for that repository. So if I do change directory, so cd, to this repository that I've just cloned, and we check all the files in the directory by doing ls, you'll notice that nothing is in there. And this is because, well, of course, it's an empty repository. We haven't really added anything yet. So let's go ahead and see if we can try to make any changes to this repository. So first things first is I'll open up Vim and I'll create a README file. And for those of you who don't know, a README file is basically it's basically a text file that is shown every time a user goes to your repository on GitHub. And this is usually done through a markdown format. Now, you don't really need to know what a markdown format is for the purposes of this tutorial, but I'll just create an example file just to kind of show you what's going on. So what I'll do is I'll just make a huge header here, and I'll just say ACM demo spring 2023, and then I can just type this is a demo for Git/GitHub, well, Git and Github for spring 2023, and then I can just save and quit this file. And so remember that I discussed if we want, so let me see, I want to make sure I did indeed talk about this. Right, so I only mentioned how exactly we get our changes remote to local. So again, like I mentioned, we basically created a clone of this repository onto our local machine. And this slide basically just talks about what I discussed, where you can download a copy of the repository onto your machine. So again, earlier I kind of mentioned that in order to have files recognized so here's the thing. So right now I've made a file. However, Git doesn't really know if it should track this change or if it should keep a snapshot of this file. So what we need to do is we need to run a command called git add. And like I previously mentioned, this just adds files that we're considering to make a snapshot of. And in this case, we're interested in that README file we just created. So I'll just do git add readme.md. And so now what happens is the Git now knows to track this README file in our current snapshot. And there's a nice command that will basically let us know what files aren't being tracked by the current commit. So if we do git status, you'll see that there are no commits yet because, well, we haven't committed anything yet. But you'll notice that it tells you that that new file is about to be committed, and this is in the staging directory, right? So this is a file that we're interested in snapshotting, but we haven't taken a snapshot of yet, to kind of refer to what I was previously just talking about. So if we're okay with the contents of this README file, which we probably are, we just added a simple text that says, oh, this is a demo. What we can do is we can now type in git commit. So now, because we're interested in taking a state or snapshot of this file, we can do git commit. Now, we can add a message to this commit by doing -m. And what I like to do personally is just I like to personally just say the name of the file, and then I like to add a colon, and then say what changes I've applied to the file. So in this case, we'll just say created the file. or created the README file. And then close the quotation. And so now it has taken a snapshot of this commit. And you may notice there's this really weird sort of code here. That is essentially the ID of the commit. So so essentially, if you look through your logs, this is the ID that that snapshot will take. So now that I've actually committed a change and I saved the snapshot to my local repository, now it's a question of how exactly do I get this change that's in my local repository to my remote repository in the cloud? Because if we go back to this remote repository and we refresh the page, we still see that nothing has actually been added here yet. So in order to actually do that, we need to add a remote repository that it knows where to keep these changes. And this is done by these two last lines here. So this line here, which I'll paste in here to my terminal, this line here, right? This basically just tells it that it's a remote repository at this link. And in the origin, so the origin is this remote repository located at this link. However, because I've already cloned the repository, I don't actually need to worry about it. However, if you were creating this from scratch, you would need to actually do this command in order to execute this, or in order to know where your changes on the cloud or remote repository are going to be at. So now the last step that we need to do is we just need to do git push, and normally we would do u origin main, and the reason for that is because it needs to know what branch, and I'll talk about what a branch is a little later on. It needs to know where exactly is this, what part of this repository is the change being committed to. So now if I hit enter, you'll notice that now it has told you that it has pushed these changes to this remote repository. And it recognizes that this branch main locally is now going to correlate to that cloud repository origin main. So this means that it's located on the remote repository. So now if we refresh the page, you'll notice that this README file has been added, but then you also have exactly the same text that we have changed. So going back to our slides here, this is kind of continuing on the discussion that we had, right? So essentially, if you were to create a repository from scratch, right, what would happen is that you would have to tell it where the destination is, or where exactly you're pushing it. So like I said, we talk about branches here, but I think we'll talk about that in a second, right? And so now I've discussed how exactly we make our changes local, which will be reflected to a remote repository. But what if someone else has made a change and we need to basically pull those changes in locally? So in order to do this, we would use a command called git pull. And essentially what this does is that it pulls whatever information is on the remote repository, and then it takes all that information and it combines it back to with your local changes. So if I were to do that here, you may notice that nothing really happens and it tells you it's already up to date. And this is because, well, there hasn't really been any changes since we've last pushed or made our local changes reflect to our remote repository. There hasn't been really any change since then, and this is why we're getting that message. But normally, this git pull is something you would do in order to fetch all the changes and then combine them into this local repository that you have set up. And again, I might have hinted at this, but this working directory state is basically when you are adding a bunch of files in Git, and you're essentially trying to know which ones to keep track of in a certain snapshot or certain state. And so this is kind of summarizing how exactly does the workflow go when you're dealing with Git. So again, when we go from the working directory, that means, right, so that's basically your coding, right? That's basically when you're making files, and you're doing all sorts of things. And then when you're interested in taking a snapshot of certain files, you would add them to your current commit. And then when you're finally ready to take all your changes and make an actual state, which can be referred to back later, you would commit. And again, when you commit, this snapshot is saved to your local repository. So in order to actually finalize the changes to a remote repository or one in the cloud, you finally need to do a git push. So those are reflected in a repository, whether that's in GitHub's cloud repository or some other on a server somewhere. And then finally, if you need to get changes from a remote repository back into your local repository, you would do a git pull, which is simply just a combination of git fetch, where you fetch information, and git merge, where you recombine all that information. So I might have hinted at the word branches, and haven't really explained what these are. I may have slipped up a couple times, and I've used the word branch. But you might ask, what exactly does this mean? A branch is essentially where you can make a duplicate of the current state of your code base. And this is really useful because what if you make a change, or you make a snapshot and that's a mistake, right? So maybe you've added too many lines, or you made a change that results in an error when someone runs your program. So a branch is a very nice way of doing this because it doesn't affect anything in your code base, in your main code base, and you can use it to work on specific features. So it basically just breaks off from your code base, and it's basically like a blank slate. Like you have this separate sort of duplicate of your code base. And so you could basically make a branch by doing git checkout or git checkout /b, and this basically just creates this basically just switches to your branch. But Git nowadays has a new command called switch, which explicitly does this. And again, these are very useful when you need to have your own set of changes separate from any other person's set of changes, or you need to work on a very specific feature. And so I'll talk about merges in a minute here, but in our case, what if we're interested in creating a new branch that has some sort of other file? So if we go back to our git bash terminal, what we can do is we can do git branch, and we can just call this new read or new info file, just for example. And now if we do git branch -a, what this does is it lists all the branches available to you. And so this is very useful because now you know that, oh, this is the remote branch, this is our local branch here, and this is basically just the branch we just created. And like I was discussing, if you would like to switch to this copy or this branch that's separate from your main, you can do git switch new info file, because that's the name of the branch we just created. And you'll notice now in the command line terminal, it sort of tells you that this new info file is the current branch we're on, and it's the current branch we're concerned with. So like I said, what if we're interested in, say, making changes to this branch, and we want to add a new feature before we add it back to our main branch? So we can essentially just reopen that README file that we created earlier. And let's say we want to add, let's say for example, I want to say add a new line. We'll say, maybe we want to change the font. We'll say this has been updated for your convenience. And we can save and quit our changes through :wq and vim. And now again, we can follow the process where we add a file, and again, we can add all files we've changed through git add period. And then we can do git status to check which ones are going to be committed. So again, these are in the staging directory. And then finally, we can commit this change, or the staging, whatever changes are in your staging directory, to our local repository by doing changed file and added new information. And so now you'll see that again, now now you'll notice that a new snapshot or a new ID has been given for a different commit, and it gives you a summary of changes. So now the question is, I've already kind of explained that you have this new branch, but how do you get these changes to merge or to combine with our main branch, or the main copy of our code base? So how exactly can I get the changes I have in this separate code base to be reflected in our main code base, or our main branch? Well, we can do this through merging, and merging essentially allows you to combine the changes of multiple branches, the change from a different branch to another branch. And this basically allows, again, like I said, this basically allows you to implement or integrate changes you've made into a separate branch, into your main branch. And so what I can do is I can just do this through git. So first I would have to switch back to main. So I do git switch main. And now what I could do is I could do git merge and then the name of the branch, which again was new info file. But I will hold off on this for now because there's something I want to discuss in a little bit. So let's say, for example, you have a new feature and you want to add that, but you also want it to discuss with people. So maybe you want an approval process before you start, completely implementing changes. Well, a lot of services like GitHub, or there's alternatives like GitLab or Bitbucket, have this thing called a pull request. And a pull request essentially allows, before files or before your branches are actually merged, it actually allows people to discuss and debate certain, changes. And if things are to be changed, or maybe they can reject it for certain reasons, this is exactly the place to do it. And this isn't exactly native in Git itself, but rather this is something that happens in services like GitHub. And usually the way you create pull requests is you'd have to have changes, if you'd have to have changes like created in a different branch, and then GitHub would usually tell you where exactly you would make a pull request. So in this case, what we could do is, I think, so now if I do git, and I think I can do, so if I do git switch and then new info file, if I do git push, so what happens is it doesn't know that there's no branch created in the cloud. So what we'd have to do is we'd have to create essentially a new branch to reflect this. And I believe if we do, so git push to origin, right? So our remote, so this is remote, or our remote location. We now need to create a branch that's specifically called new info file. And I think if I do this, it automatically creates said branch. So now you'll notice actually that when you do this, you basically need to have that -u to set the upstream branch. So it knows where exactly am I pushing these changes. And again, this origin is essentially just a remote location. So in this case, obviously, it's the link to our repository. And then afterwards, you can specify a branch. And again, we call it new info file just to reflect exactly what it was locally. So if I go back to GitHub and I refresh the page, you'll notice that GitHub actually tells me that this new info thing had a recent push a minute ago, or the remote was recently changed a minute ago. And in fact, if I go to this little drop down here, I can see that this new info repository was actually added. And if I take a look at it, we can see that if you notice, this branch has this little text we added and has changed this to a subheader. But if you go back to our main branch, you'll notice that these changes aren't reflected. So again, this is what I was discussing. So before we actually make changes final, we can do something what's called a pull request. And a pull request will allow us to make a thread, so kind of like a discussion forum, and explain what kind of changes are being implemented. So I could say, so this is basically the summary of the change in that previous branch. And then I can add a comment like saying, I modified a README file for the purposes, if I could spell, of demonstrating a pull request. So now, if you create this pull request with this comment and this main header here that reflects the changes that you've combined, you'll notice that once you create this thread or this pull request, it'll check if you can actually merge these two branches. And then finally, when you can click merge pull request to finalize that pull request, and this will actually merge all the changes done in one branch to another branch. And so if we actually go back to our code, you'll notice that main has actually been updated with all these changes. So it's a very nice system of you can, have changes that are completely separate from, your main code base, and then you can later integrate them back with discussion or suggestions or that sort of thing. So if we go back to slides. again, these slides are just demonstrating that, again, what we can do is we could just create a pull request, make a thread, people can discuss, and then once people are happy, you can actually finalize that pull request and then merge all the changes from one branch to another branch. So that pretty much covers all I would like to cover for today. There are definitely some topics which may warrant discussion, like, for example, what Rebase does. But for being straightforward and simple, I will keep it as is. And so again, if you want to sign into today's meeting, just make sure you check that QR code. But with the little time we have left, I'll go ahead and answer any questions in the chat. I know I saw one earlier. Okay, so Zunuba asks, can we think of using Git with a command line? Thank you. Can we think of using Git with a command line and GitHub as the GUI of it, or different? So I think that's somewhat accurate, because what you can basically do in Git, you can actually do in GitHub. In fact, there is a GitHub desktop which has a GUI which allows you to change these sorts of things. But I would say maybe GitHub is a little different, because GitHub is the actual service behind hosting these repositories in the cloud. So it's not necessarily a GUI version. It's more of like a centralized version of Git, so where it holds all these repositories in the cloud. However, you are right in the sense that you can technically make changes in the GUI without having to interact with the command line. In fact, there is a GitHub desktop application which I can actually show you here now with the time we have left. And then let me just see if I could switch to the repository I was discussing. Let me see. So let's see. Right. So so this, for example, is how things would be reflected on the GitHub desktop application, right? So what's nice is that you can do this all entirely through the GUI, and we can even see a history. So, for example, this is exactly what I did, where I, modified this README file to, have a different header and then some other text. And then you can also see some history changes. So this is the very first time we created the file. And then we can even see which branches to compare. So we can compare back to main. So if, for example, at that state, main was different than this branch that had these changes there. And you can definitely add more repositories and you can definitely also do it through the command prompt, but this is definitely a way of doing it through the GUI. And it's also might be more friendly, so you can actually navigate through the file explorer. You can view the actual repository on GitHub itself. If you are intimidated, well, if you prefer having an actual user interface to do this stuff, then I would recommend installing this GitHub desktop application. And I can definitely get you the link, or if one of the stream moderators are okay with doing that, that's perfectly fine too. But this is just an option in case you don't like using the command line very much. This is definitely an option you can use. And I hope that answers your question there, Zunuba. And I don't know if anyone else has any other questions they can think of. Yes, thank you. Yeah, that's the link. Thank you. So I'll give it maybe like 3 more minutes, and we'll see if anyone else has questions. Oh, and also, for those of you who are here for the extra credit and you would like the sign-in, please just let me know, and I can pull the sign-in back for those who want to make sure that they actually get extra credit for at least checking out today's event. Okay, let's see. Anyone else? Any questions? I guess another thing I want to add while I'm here. Um, I know a lot of you may have been required to sign in when you have Git Bash. Well, so uh, a lot of the credential stuff, or so signing in from your machine, you don't actually have to worry too much about that stuff because I believe the first time you clone a private repository or you make any changes, GitHub actually prompts you to sign in. Although there are ways of caching your credentials, so you don't have to sign in every time. But that's kind of out of the scope of the stream. But you're totally welcome to ask that question on the Discord, and someone can definitely help you. Um, but yeah, with that being said, I think we're pretty much done, right? I don't see any other questions from the chat here. But yeah, so I guess just to wrap it up, thank you guys for tuning in, and make sure you're on the lookout for not only tomorrow's events but our technical workshop next week. Um, but yeah, again, I know today's a bit of a different day, so I just definitely want to say thank you guys so much for at least taking the time out of your day to watch today's stream. So yeah, no, thank you guys. Take care. Thanks for tuning in.